Let's see this question. We have given two circles are there with radius R1 and R2 and their centers that separated by a distance of d units. We have to find the length of common tangent AB. So we'll start our question by joining OA. That's the radius of the circle. So let's join OA and O dash B. We know radius is perpendicular to the tangent. So this angle is 90 degrees. This is 90 degrees. These are forming your co-interior angle. Sum is 180. So we can say these lines are parallel to each other. Also, these are radius. So this full length, that's your R1 and this length is R2. We are drawing a construction here that is from point O dash. I am drawing O dash M, which is parallel to AB. So these two lines are parallel to each other. So let's draw this as parallel. And this is your M. Now this particular figure, that's your A, B, O dash and M. This figure is a parallelogram because opposite sides are parallel and thus the lengths are opposite lengths are equal. We can say that AM is nothing but R2. If AM is R2, then OM is nothing but R1 minus R2. Also opposite sides are equal. So AB is equal to O dash M, right? This is equals to AB. And here we'll concentrate on this particular triangle. Now also in this parallelogram, one angle is 90 degree. So this particular figure is nothing but a rectangle. So this angle will also be 90 and this angle is 90 degrees. So in triangle O dash M, by applying Pythagoras theorem, what we are getting is O dash square, which is a hypotenuse, is equals to OM square plus O dash M square. O dash, this is given to us as D. So D square is equals to OM is R1 minus R2 whole square plus O dash M. Now O dash M, we know that that's nothing but AB. So AB square. We'll say AB square is D square minus R1 minus R2 whole square. And AB is square root of D square minus difference of the radius, that's R1 minus R2 square. This is the length of tangent which we had to find, and that's our answer. I hope the solution is crystal clear to you. And this formula again is a useful formula which can be used directly in a lot of MCQ questions. We'll see you next video. Till then, tata, bye bye.